Hello, everybody. Welcome to another edition of Biology in the Basement with your host, Mr. Andraco. The purpose of this video is to do a quick review of muscle, bone, and skin. I lump these three systems together as kind of the nuts and bolts and structure of your body. So before we move on to the two bosses of the body, we talk about the nuts and bolts. So we're going to do a quick review of this and then set you up for what you need to do and send me to wrap up this three body system section. So let's have a fact of the day before we get started. This one is very interesting because we've been just talking about viruses. They're in the news all the time. And it seems that scientists have been able to track the history of the AIDS virus, right? The research believed to be patient zero, which actually is not the term they use. They call it index case. So if we want to be the actual guy. But patient zero, or the index case, the first known case was a person who lived in Cameroon, Africa, contracted the disease around 1908 after hunting a chimp and being infected with what was known at the time as simian immunodeficiency virus, SIV. So this was the first recorded case. So there most likely were hunters in Africa that were hunting chimpanzees and eating the meat. And they contracted AIDS from this. I hate to break it to you, that didn't get it the other way, that most people say we got it. This is also a reason why it's not good to be a cannibal and eat your own meat or your own muscles, because any diseases that are in the muscles, even though you cook your meat and things like that, can still transfer. So it's not good to be a cannibal for many reasons, but one of them is it's easy to get diseases from the same type of meat, the same type of cells, or similar, like a chimpanzee. So there's your fact of the day so that we can get started. Here we go. Muscles. All they do is they move stuff. Big stuff, small stuff. We talked about the three main types, the ones you normally think of, the skeletal muscles that are attached to our bones, that work with levers and pulleys to move things around. But we also have internal muscles, these smooth muscles like your diaphragm, your esophagus, your stomach, your intestines, even your blood vessels pushing your blood back, your irises. These are all smooth muscle. And then the one that kind of lives in both camps is cardiac muscle. The reason why we classify these, or the way we classify them, is by two main factors, and the table in your homework went over that, right? Where these guys are voluntary muscles for the most part, and they are striated, meaning reinforced, where smooth muscle is the opposite, where they are involuntary, and these cells are non-striated or not reinforced. These are the things that are usually controlled by the lower brainstem activity, which we'll get into as we talk about the nervous system. Spoiler alert, that's what's coming up next. In both camps, you have cardiac muscle, right? It is reinforced because your heart can jump to a very high heart rate very quickly, so we reinforce it, but it is also involuntary. Thank goodness that we don't have to think about reminding ourselves to have our heart beating and have ourselves breathing and doing all of these involuntary things, or we'd be in a lot of trouble. So as you can see here, we have what a muscle looks like, right? Where it has these thin fibers that are surrounded by these thicker fibers, and when they act as hooks, they work as a controlled flexing of the muscle. When I teach anatomy and physiology, I talk about the 5 points of muscle movement, right, where muscles can pull, never push, right? So they have to be in opposing groups. We also talk about how they have to cross one joint because they do act as levers, so they have to be attached. That's where your tendons come in, right? So that they cross over a joint. So when they contract, right, they pull towards what's called the insertion point. And so that's the gist of the 5 golden rules. But that's how your muscles work, right? And we talked about opposing groups, arms and legs are good examples. Got into the skeletal system as well. Obviously, we support the body. We looked at Bonesy when he didn't have his clothes on, and you can see how he has a nice rib cage and a skull protecting internal organs. As I just said, we've got tendons helping connect to muscles so that we can provide for movement. We store our minerals like calcium, magnesium in there for when we need them for other things, as well as it is a factory for red and white blood cell formation. So I talked about the bone as one of the most overlooked awesome organs. The bone is super lightweight because it has spongy ends, soft marrow in the middle, but this hard, compact periosteum on the outside. So it is super strong, super lightweight, as well it is a factory for blood cells, right? The marrow. Of course, when we start to think logistically about a tough outer covering and a factory on the inside, we need to understand the logistics. And so we've got these Haversian canals that run pores through and have channels inside to send blood through the blood making sites, our marrow, so that the raw materials can go in and our blood can come out, those products that are being made. Here are the different types of blood cells that are made in your marrow. Obviously, your red blood cells and many different types of white blood cells. We can also recycle the platelets from red blood cells in our marrow. That's another job for an organ we haven't really discussed, which is your spleen. Your spleen is a blood reservoir which holds a lot of red blood cells, and it also does the same job of recycling red blood cells into platelets. So, cartilage. This is a connective tissue. It is soft like bone. But it is soft like connective tissue, but sturdy like bone. Spencer, I saw your comment, so this is directed towards you, where you had asked, is it true that cartilage can become bone? And the correct answer is yes, right? Ossification is what happens to babies as they grow older, right? When you see babies bonking their heads and hurting themselves, you're just like, they're fine, they're rubber bones, you know. Yes, their bones are more like cartilage, and they undergo this ossification, which is a process of calcium, cartilage becoming bone. So I hope that answers your question, right? Because you touch a baby's head and it's very, very soft. It's still considered cartilaginous, and then it will eventually form and harden into a good solid cranium. But yes, so good question, Spencer, and don't be afraid to text little questions anytime. You know me, we would digress for long periods of time asking things like that. So we also use Bonesy to show how in our joints and our discs of our back, connecting our sternum, even our trachea, holding our windpipe open, are all places where we find cartilage, not just our nose and our ears where we may normally think of. A joint, there's many different classifications: movable, immovable, slightly movable, or the different types. I'm not too worried about it, just so that you understand, your elbow is a good example of a hinge joint. Your hip and your shoulders are a good example of a ball and socket joint. your pivot joint in your neck where those vertebrae are kind of just sliding. Of course, it's a collection of vertebrae that are sliding. And the cranial joints, as we just mentioned, those slowly form over time, and those are the one immovable type. Your saddle or gliding or things like that, right? Those are found in your wrists and other places like that. I did my funny little thing on my stool about the two parts of the skeleton. Don't forget, get your bone worksheet pictures into me. Connective tissue showing those different types where we have tendons connecting muscle to bone and then ligaments connecting our bones together in our skeleton. Last part, obviously the skin. It is another very interesting adapted organ. I'd probably still rather go with the honey badger skin. It's just funny that I still think about how funny that is, that like the words they used were like machete and spear. Like the honey badger has been a problem for many years, that they've been trying to chop and spear this thing just to kill it and get it away from, scavenging their food or whatever problem the honey badger is causing them, and the fact that it said the best method was to club it, its skull, which was probably pretty hard, I would imagine. But anyways, our skin is totally awesome too, helping us to survive in those really hot environments. And that makes up most of the integumentary system. Skin is one of the organs of the integumentary system, along with your nails, hair, sweat, and sebaceous glands are included as well. And we talked about these pretty much already, where we protect the body against infection and injury as our first line of defense. We work with our blood and just opening and closing of pores to regulate body temperature, as well as it works with the immune or the excretory system, where we also send blood vessels to the skin to remove wastes like heat, water, mineral salts, uric acid. And of course, the last one I tried to very slowly explain, that UV radiation, right, is a type of radiation along with chemicals that cause mutation in cells. So every species has evolved to protect its internal cells from UV radiation, so that UV radiation doesn't hit your internal cells, because it will cause mutation, which would eventually lead to cancer, right? The reptiles have scales, birds have feathers, most mammals have fur, and we have a layer of dead skin covering over our body to protect ourselves from UV radiation, because it is bad. So no, we don't want to expose the inside of our body to UV rays, because it would cause mutations that would eventually lead to all kinds of cancers and weird mutated cells. So just remember that. Okay, so here is your cross-section of skin with all that cool stuff going on. One of the things I forgot to point out was this piloerectile muscle here. This is the muscle that when it contracts, right, it makes your hair stand on end. Now, this is semi-vestigial, where my cat is a good example of when it comes in the morning after being all night, it's just this big puffball, because all of its hairs have stood up on end to give it that extra insulation. It also uses those hairs on the back of its neck to make it look bigger and scarier. But of course, we've talked about this, that those things are vestigial. Of course, it also does close up our pores at the same time, so not quite unnecessary. And that's it. So that finishes your section on skin, muscle, and bone. So Your two assignments to wrap this up are to do objectives 42 through 55, right? These are the objectives that cover muscle, bone, and just the two for your integumentary system or skin. And then included in that, always your favorite, the crossword puzzle. So this will be kind of your mini quiz. So I would like to see you share this section with me, and I would like to see a picture of this. So I'll give you whatever, the rest of the week and weekend to do these things to get this stuff into me, and we'll wrap this up and we'll start the nervous system fresh next week. Okay, so signing off. Have a good weekend, and we'll see you soon. Miss you guys, and hope that all is well.